Meow 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 meow.
Welcome back to the Super Circuit Bending Super Show. This is the part 2 of our Meowsic with a LFO Pitch Mod built in. Last time we put together a pitch mod that basically changes the clock speed. What we're going to put together next is this little module. And what this is going to let us do is, instead of using our knob to adjust the pitch, or clock speed, same thing, this is going to create a little, basically just a simple little circuit that changes an LED's brightness up and down with a waveform similar to what you might see on a synthesizer's LFO. So that's why I kind of refer to it as an LED LFO. And the reason we have it drive an LED is then we can use a light-dependent resistor on the end of the LED. When you combine the two, it creates something called a Vactrol. And that Vactrol will let us, basically replace our knob with something kind of automated, so we can put like sweep patterns and things like that in, instead of just having to turn the knob manually. So this module is one I've been working on for a while. This is an old version of a PCB I had done. I'm working out some kinks, but eventually I would like to sell a kit of these that'll be pre-built and come with all the stuff you need to assemble one easily, blah blah blah. I thought I had that figured out until I was getting ready for open source. I was building a Meowsic, pretty much just like the one we're building now, and in my head I thought, oh, I've got these circuits down pat, this will be really easy, and both of those things were wrong. It was not easy, and it ended up not working at all, and I was really confused as to why it wasn't working. So as part of working out those kinks, I'm kind of going back to this older version. I breadboarded this out the other day. It worked perfectly fine. None of the issues I was running into before cropped up. So this might be bumpy, it might not. But anyway, long story short, eventually I hope to have a kit of these up for sale on the website. If that has happened, hopefully I'll remember to come update the description and put some links in there for everyone. If I haven't, you can just build this circuit. It's very straightforward. I've got the schematic up on my GitHub. Pretty much everything I do is open source, so feel free to just go build the circuit yourself if you're familiar with putting together circuits, reading circuit diagrams. If not, this might honestly be a good project if you're interested in learning how to do that, just because it is a pretty straightforward little circuit. And as part of this video, I'm going to kind of talk through assembling it on a PCB, just to, kind of talk about what the circuit's doing and all the various settings we can change, things like that. So the first thing we have is our only IC, or chip, you might refer to these as, but IC is just, basically a fancy word for a chip. This is a TL072, which is just a simple op amp. These things are dirt cheap. When I was designing the circuit, I wanted it to be as cheap and use as few components as possible. So that's how I landed on using some of these things. First, we're going to put on resistors, and then we're going to put on the IC. Basically, you want to start with the flattest components and work your way up to the tallest. So the last thing we're going to put on is capacitors and stuff like that. The first thing we need to do is just populate these resistors. I grabbed these off my breadboard, so I just kind of need to check them as I go to see what they all are. Basically, I've got these little resistors here I pulled off my breadboard. In the interest of recycling, I'm going to keep up with these. So that is a 220 ohm, a 22 kilo ohm. familiar with putting together PCBs, you're going to think, oh gosh, this is looking ugly, but that is fine. It doesn't need to be pretty. This one is a 100K, and then if you ever end up in a situation like I have, where you really mangle the placement of one of these, the trick you can do is take the loose end, grab your needle noses, and just kind of twist it until it comes through. Now it is laying nice and flat. You shouldn't have to do that, but since these are all, I'm not a very tidy breadboarder, so these are a bit of a mess. So this one is 470 ohms. I'm going to set that one aside because that is our control resistor, and I'll chat a little bit more about what that means here in a moment. It's 47K. This is 100K. Which matches, that's good. I mean, that likely didn't screw up along the way. So that is most of our pile of resistors. Now, I mentioned earlier I was setting aside this guy, and I called it the control resistor. So this circuit, one of the unique things about it, is it can be configured with different ranges of speeds. So, basically there's a capacitor and a resistor that control the rate at which the LED brightness increases and decreases. And I put together a few suggested values. But basically, the lower this resistor value, the faster the LFO range goes. So you can set this really low and make like a really slow LFO, like so impossibly slow that it would only be good for like weird experimental music stuff. The values that I'm using here, which is the 470 ohm resistor and the, I believe this is a 47 microfarad electrolytic capacitor. That's what I would call kind of like the normal range. It lets you go really slow still, but not like imperceptibly experimentally slow. And then if you went with like a 1K resistor and I think it's like a 10 microfarad. I've got, they're written down on my GitHub what they specifically are. But basically that will give you like a really tight control over like a more musical range. This one, since it's a fun circuit bent toy and I can see, wanting to use it to make some weird sound design stuff, I am gonna just kind of go ahead and shoot right up the middle and use the 470-47 combo. But yeah, I just wanted to explain that real quickly before I popped this guy in. Yeah, this resistor over here is that control resistor. Now, eventually, this same circuit should also be able to add CD control using the same Vactrols. That's what I thought I had done with the upgraded version, but it turns out I was wrong. It did not work. This resistor that I'm putting in, each LED needs its own resistor to basically just to control how many amps it can pull. And so that's this resistor. It's very low value. I think it's 220 ohm. And basically, it's just there so that this specific LED won't get blown up or anything. Now, I'm only going to install one LED on the board. There's going to be 2 more indicator LEDs, but another thing this board can do is it has a separate connector where you can run a bus off to add as many more LEDs as you want. So in this particular case, we're going to add a couple of LEDs onto the Cat Keyboard's eyes, and that way to see what the LFO is doing, you can kind of watch its eyes kind of blinking and change as we go along. Now, the next thing we're going to do is there are 2 diodes here. And since those are also really flat, small components, we're going to go ahead and install those alongside the resistors. What these are for is using a saw and reverse saw wave. So this circuit is capable of doing 4 different wave patterns. It's able to do a square wave, which is basically just turning the LED on and off. It can do a triangle wave, which is just an even ramp up, ramp down. Then it can do a saw wave, which is a ramp up, and then an immediate drop down. Or it can do a reverse saw wave, which is an immediate jump up and then a ramp down. So you can do all 4 of those waves. We are going to configure this one, just because the square wave is a bit boring to me, and the saw waves are basically just modifications of the triangle wave using these 2 diodes. So we can actually save ourselves some control by limiting it to triangle saw and reverse saw. So we still get 3 different waveforms, and then we only need to set this up using one switch to control which waveform we select. But that said, if you just wanted to do triangle wave, or you just wanted to do a triangle square, you wouldn't need to add these diodes in. So these diodes are 1N... It's shiny, hard to read. It's a 1N4148 diodes. These are super common little signal diodes. Don't need anything terribly beefy for this. And if you're relatively new to this stuff, what diode is you can kind of think of it as a one-way street. It basically lets electricity pass only one way through it. Is a really simple way, but effective way of thinking about it. And because they are one-way streets, which way you put them in matters. So always good to double check, make sure they're in right. So our next step is just to solder all these guys into place. Zip in a bit here. Alright, here comes the fan. bit haphazard, but I think I cut them all. That's one of the reasons my soldering mats are always a huge mess. It's all the flux I use. And just in case you missed the first episode, or the first part of this episode, I think is how I'm gonna break it up. Long story short, the reason I solder all wrong, I'll be honest, it's not the right way to solder, is because I had a stroke about a year ago, and so while I've been able to get the use of my left hand back, and it's really shaky and doesn't quite have the motor coordination one needs for soldering. So basically I do what you're not supposed to do, and just scoop up solder on the soldering iron and deposit it. Which again, you're not supposed to do that. If you're learning how to solder, do not look to me to learn how. Just because that's not a good way to do it. But you can kind of get by doing that, if you have to, by dumping a lot of flux onto, everything to solder. Which is what I do, more out of necessity. But, yeah, just to explain what's going on with that, and also, if you see my hand shaking around, that's normal. It just does that now. That one joke's not good. I'm gonna fix that real quick. Next up, we're gonna go ahead and put our IC in place. This stand's just a bit taller than the resistors in that. And just like before, get that soldered in. Here comes the fan. Saw me fiddling with that there. What I was doing was, basically you just want to solder one corner until you get the IC laying flat, or flat enough that you're okay with it. This isn't perfect, but again, good enough for what we're doing, and, working with one hand makes it a little trickier, so I tend to be more forgiving of that stuff these days. So. Next up, we've just got to attach our capacitor and LED. First, capacitor in. Just a reminder for anyone who may be newer at this, electrolytic capacitors are polar, which means it matters which way they go. So making sure to get the positive and negative in the right positions. I don't think I'm going to be starved for space, but I'm making sure I leave enough room that I can kind of bend the capacitor over like so. That guy soldered in. Here comes the fan. And next, we're going to install our LED. Now, one of the problems with this old board is it doesn't actually tell you which side of the LED is positive, which side is negative. I seem to recall these resistors are tied to ground, but I'm just going to check that real quickly. That's right. It's the resistors, basically by the circuit. It's a little over my head. I borrowed this, modified it from folks I saw online talking about doing a similar project. It basically uses the fluctuation of the ground and voltage to dim the LEDs. So long story short, positive side is the outside, the ground side is facing the LED. It just doesn't read as ground because it's not directly connected to ground. It's coming through that op amp. So LEDs, since they are diodes, they are also one-way streets. The trick for telling which way is positive and negative, if you're not already aware, the positive leg is longer, and there's a little flat end. Let's see if I can get this thing to focus on me. There it is. Forgive the messy fingers, but you can see it. The edge on the negative side, the shorter leg, is flat. It's not round all the way around. It's pretty hard to see on camera, but it's much more obvious in person. But yeah, by looking for that longer leg, or if you've accidentally already trimmed the legs, you can look for that flattened edge to know which side is which. I'm sure there are other tricks for LEDs, so feel free to drop those in the comments if you've got a good one. And on this one, I'm also leaving plenty of room, because when I make the Vactrol, I'm going to want to be able to bend it down like so. So while there's plenty of room inside the Meowsic case, I just want to be sure I don't run out of space. Alright. Let's bring this little last bit for now. Here comes the fan. got a couple more bits to solder in, and then we can finally start cleaning up some of this flux that is gotten everywhere. Super annoying. So, like I mentioned before, this module can do 4 waves total. So there are 2 places on the board. Zoom in. So there are 2 places on the board for switches. One switches between triangle and square. This one switches between saw and reverse saw. And remember, saw and reverse saw just modify the triangle wave. So it has to be in the triangle wave over here for this switch to do anything. So rather than hooking up 2 separate switches, I'm just going to use a little component leg to jumper off so that it is always in triangle wave mode. As I mentioned before, a square wave is just on-off, which could be super useful in some applications. But for a pitch bend, I don't think it's very exciting. So to make that easier, I've labeled those here, where the C is the common connection, S is for square, T is for triangle, same thing, common, saw, reverse saw. So here, I'm just going to jumper the common to T for triangle. Now the other thing I'm going to do is you'll notice there's a spot for 2 different knobs here. One is the depth and one is the rate. Now the depth, that's a control that lets you adjust the overall brightness of the LEDs, high or low. And for something like this, where we're running with a really low voltage and we're not trying to do anything too fancy, it's just a circuit bent toy, I don't find the depth to be very necessary. So instead of installing a knob or a resistor there, I'm just going to jumper this off so that that way it will be at maximum brightness all the time, which is what I want for this project. Now that said, if you had something where you did want to control, if you had some sort of really subtle effect that you wanted to, or rather some sort of effect or something that you wanted to be able to apply really subtly, leaving in that depth control would probably be a great way to do it. Then you can basically fine-tune the overall impact of the LFO range on the Vactrol. I think we're finally at a spot where we can clean up all this flux. Yeah, it's everywhere. So if you don't know, flux can be really obnoxious and sticky and get all over everything. It's terrible. And basically the only thing that gets it off is isopropyl alcohol. I'm sure there's other stuff, so let me know if I'm missing out on a cool tip. But, yeah, the worst is when it gets all over your fingers, and, yeah, even, washing your hands in the bathroom won't, do anything. It's... to break the stuff down or whatever. So, there's a ton of flux like this. I tend to just douse the board, and then come along with a Q-tip. If it's just a little, you can use away your Q-tip and go from there. But it is important to use a Q-tip or a cotton ball or basically something to get it off. Otherwise, you're just kind of like spreading the flux around. Still forming. Here we go. I will say I do use a no clean flux, so if any flux stays on the board, it's fine. Some of the old fluxes used to like corrode through the board and really mess things up if you left it on there. But the modern no clean stuff doesn't do that. So if there's still some flux on the board, the only downside to that, as far as I'm aware, is it's sticky and annoying. But just leaving it on there, just getting the majority of it off is fine as far as the actual functioning of it goes. Alright, we are back. Had some overheating issues there, so hopefully in post I'll be able to clean that section up. But basically, we've got everything wired up on our board here. Last things we've got to hook up are just our switch that will control which waveform we're using. Our rate knob is going to determine how fast the LFO goes. And then we're also going to hook up some wires to the LED bus. Later we're going to hook up some indicator lights to show us what the to show us what the LFO is doing. And then finally we're going to hook it up to our power supply that we set up earlier. And then we'll test it out, and if that looks good, we will start the process of wiring this thing into our existing pitch mod. So it occurred to me, I totally just jumped into this one without talking a little bit, so I'm kind of going to do intro material while I'm cutting wires and stuff, rather than fix it in post, because I'm lazy. And long story short, just to recap what this series is all about, it's kind of just about showing the process for circuit bending projects. So this whole series is about showing the full process, kind of demystifying it a bit. It's also, just a fun way to show how these projects work. For some reason, I feel like electronics always feels way more inapproachable than it actually is. So, hoping that the kind of off-the-cuff, showing the full process, minimal editing approach will kind of help with that. And I don't know, if nothing else, maybe it's good to fall asleep to or something. While I drone on about trying to wire things. Anyway, alright, I've got my wires cut. First thing we'll wire up is our switch. So I'll grab it, this little guy here. Now, I think I've shared before, just to make sure I reiterate this, the way I hook up these switches is more to do with the fact that I only have one good hand, so it helps me out. Basically, I strip off a really long end of the wire, and then I'll work it through one of these holes, bend it over, and once it's soldered in place, I'll trim off the excess. Now, if you can use both your hands, you don't have to do any of this. You can just put a little blob of solder on the contact, put a little bit on the end of the wire, get that tinned, and then just heat them up and stick them together. So, definitely do not recommend soldering the way I do if you have the option not to. And splitting the ends there, so just twist those back. One on the strand just does not want to behave. Good, so I'm just going to go ahead and solder these in. So here comes the fan. I think I mentioned this before, but with these super cheapo switches, it's always good to move fast. So it's really easy to overheat them and kind of burns up the internal switching mechanism stuff. And they do not work very well. Let's give this one a toggle. It seems to be toggling well still. If you accidentally overheat it, a lot of times it'll kind of feel stuck. So you'll be able to kind of feel it out if you've accidentally gone a little bit too hard. So we've just got to get this wired onto the board. If you can't see it, it'll be in this connector here. We've got the C for common, the S for saw, and the R for reverse saw. Now in this case, it doesn't really matter which way I hook it up as long as this white wire I put in the middle goes to the common connection. The other two colors really don't matter, so when it will matter is when I go to kind of place the controls and label things. I want to make sure I know which direction saw, which one's reverse saw. So here, color coding the wires will be really helpful at that phase, but for right now we can just kind of do it whatever color into either the saw or reverse saw. Then, as I did with our pitch control, I'm not gonna make like a super fancy coil or anything, but I'm just gonna wrap this green wire around the white wire a couple times. That will help keep track of things as our nest of wires starts to develop. then, just like green wire, I'm going to wrap the yellow wire around a couple times. I didn't make it look super pretty. It's just going to keep these wires grouped together for me when I start installing things. I'll be the first one to say my wire management sucks. It's not going to be pretty no matter what I do. So this is just more about trying to make my own life a little easier when it comes time to package everything up. Rotate this board a little bit so I can get to the other side. So you can see having these nice long ends on there means all those wires stay in place. So next I'm just going to get those soldered. Here's the fan. And now we will just clean up these ends. Get that switch connected. As you can see, the wires are all the same length, so it doesn't look very pretty, but they will stay kind of bundled up together. That whole winding. That is A-okay. Next we've got our rate control. This is a 100K linear potentiometer. And just like with our rate control, this is another one that I had previously soldered some wires onto. It's like that one. I'm just gonna scrape those wire ends off and replace them. Now, it doesn't really matter which one's, 1 and which one's 2 when we connect it to the board, so it doesn't really matter which one I connect the colored wire to. The only thing that does matter is, again, just like in the first part, when we were dealing with our pitch mod control, we want to use these 2 pins. That way when we turn clockwise, we're turning the resistance down between these 2 points, which increases the speed of the LFO. And we want turning clockwise to turn the speed up, just so it feels more natural. If we did put it in backwards, using these 2 pins, it wouldn't hurt anything. It would just feel, it would feel wrong. Our other one, what I'm doing now is stripping off some end of these wires and making a loop. So once I clear these off, I'll basically be able to hang these little wires on the contacts like that. And that isn't necessary. That's more one-handed coping mechanism thing. So yeah, it kind of stays in place while I get after it with the soldering iron. Alright, so now I've got those set. I'm going to fire up the soldering iron and the fan, scrape those contacts off, hang the new wires, and then solder them in place. Here comes the fan. that. And then, just like before, I'm going to kind of wrap these wires around each other a bit. That will stick together since, as you've noticed, I've got a few different yellow and blue wires and red and black wires building up, so making sure they're kind of grouped together that way would be a big help when it's time to start finalizing things. And right here, this is where we attach our rate control. It doesn't matter which color wire goes into which hole. The thing we really have to pay attention to is which pins we use on the potentiometer. Alright. Now we are ready to solder those in. Here comes the fan. Good, so now we've got all our controls hooked up. Last step is we'll bring the keyboard back over here, hook up the power, and, oh, I lied. We have more wires to hook up, and that is the USB bus, or USB, the LED bus wires. These two connectors are labeled as V+ for positive voltage, and output, which is the output from the LFO, which, as we remember, goes to the ground side of our LED. So that's why I'm marking it with a black wire, is to remember that that goes to the negative side of the LED. That way I remember not to hook anything up backwards. Now, one thing to note, when using this bus, you still have to attach a resistor to every LED that you add onto this bus. That way you have the overcurrent protection and don't burn up your LEDs. Okay, now let's solder these in. Here comes the fan. Alright, so now we've got these hooked up as well. So we're ready to attach our signal LEDs. Alright, so zooming back out, we can kind of catch up from part 1 of this episode where we installed our clock modder. What we have here is a pitch control that adjusts the clock speed up and down, as well as a switch that turns the clock mod on and off. We also have over here a little power bus that we put together. And the first thing we're going to do is use this to provide power to our little LFO board. Get these soldered in. Here comes the fan. Cleaned up. And I think I mentioned this in the part 1 of this video, just to make sure I put it in the part 2 as well. I'm trying to make the process easy to follow along. If I miss anything, if I jump past something, or if you have any questions. The nice thing about being a teeny tiny channel is I can actually keep up with and read all the various comments and stuff, so feel free to ask away. I can see those and will definitely do my best to answer any questions. Cool. So this guy's all wired up. Let's cut it on and see if it works. Alright, that is a good sign. You can see the light is pulsing. As you can see, this is our triangle pattern, so it's slowly ramping up the brightness and then coming back down. And if I adjust the speed using our rate knob, we can make that go. And a little pulse, we can make it really fast. Turn it way down. Like I said before, you can make it go really slow. Find a good middle speed and check out the other waves, make sure they're working. Let's see if we get a nice pulse going. So you can see here we've got it's jumping straight up to right and then reversing down. And there's the reverse saw. This is the opposite. Perfect. Alright, so now that we've confirmed that's working, the next step is to hook up our LDR. Now, light-dependent resistors have really weird values. Zoom out a little. They have really weird values, so I use a little bit of shorthand. So this one is called a 5606. That's the designation for just the one that I've found works well. And this usually, as long as it's receiving light, gets in the range of 1 to 5K resistance, roughly. And note that I say roughly, the downfall of setting up Vactrols like this is they are very imprecise. So perfectly fine for a little circuit bending project, but if you were trying to do something deeply musical, LDRs aren't amazing for that, just because they're very, they're not precision instruments. But I definitely encourage folks to play around. This is part of the fun of circuit bending is, tuning it to your liking. You may find a different value responds a totally different way, and you like that a lot more. But how we're going to connect this, we're just going to use a bit of shrink wrap tube over this LED, and then we're going to shove the LDR in there. There we go. So you can see the top of it has this little sensor area. And we're going to point the light right in that, since that's the kind of light reactive portion. Hopefully I didn't totally lose my train of thought there. But, alright, so next step, we're going to turn this LED into a Vactrol by sticking our LDR, or sometimes called a photoresistor, basically right up against it. Position so my hand isn't completely in the way. It's going to be butted up against it just like that. And you can just use electrical tape to do that, or whatever you want. I find it easier to use a little bit of heat shrink tube. I think this is 1/4 inch 3:1 ratio heat shrink. That seems to work pretty well. So yeah, basically I'm just going to slide it over my LED. Make sure it's as far on as it goes. Make sure this goes as far in as he goes. Bring over a second clip just to kind of hold it in place to make sure that doesn't happen. And again, there's no real accuracy with these things, but what you don't want to do is to have, basically the shrink wrap create any sort of a gap in between the light and the resistor. So I've got it butted right up against there, and I'm going to use a hot air gun to shrink this because I have one. If you don't, that's fine. You can just use a lighter, do whatever you want, and that's totally fine. I just happen to have a hot air gun, so I may as well use it. Alright. So you can see that shrunk up nicely. And just to kind of demonstrate what this does, I'm going to get out my multimeter here. And how this works is basically the more light is shining, the less resistance there is between these two poles, or two leads, whatever you want to call them. So as you can see, right now it's reading at like half a mega ohm. So when there's no light at all, these things like shoot up to really high resistances. And you can see there is a little bit of light leakage, because if I hold my hand over it, it jumps up to 1.2 mega ohms. So once I've got this all hooked up and working, I'm probably going to throw some electrical tape on there for good measure, just block out any outside light. That way the only thing affecting our little Vactrol will be the LED light. But now, let's turn on our light and kind of watch the resistance change. Turn it down a bit so my meter can try to keep up. So you can see my meter's doing its best to kind of track along. But, ticking up and down, changing as that light goes. So if I peek in from the back, I can see it glowing just as we would expect. So we know it's working, even though we haven't hooked up our indicator lights yet. But yeah, basically that's what this is going to do. Instead of using our pitch control knob, we're going to set it up so that we can change the resistance using this guy. Now the next part, I kind of always forget how it works, and rather than like figuring it out off camera, I wanted to demonstrate one of my favorite little things, which is using alligator clips. So these things to me are like indispensable when you're circuit bending, because it lets you wire stuff up temporarily and play around with it. That way you can kind of test out a theory without having to solder anything, blah blah blah. They're incredibly handy. So, I'm trying to remember how I hooked up the Vactrol to to our pitch control knob to make it work. Memory serves, it may just be in parallel, meaning we just connect them right to the same place. The wires are already connected. Oh wait, no, after that. So basically, we'll connect these two, to the knob in parallel. Then we'll have one of these just go ahead and attach directly to our Vactrol, and the other one will be connected to a switch. So when that switch engages, it will utilize our, I'm going to try it without desoldering, but I may need to desolder something. And this is why the clip-ons are great. We can just try this real quick, and if it doesn't work, we'll try something else. Move this in frame so y'all can see it. So on the switch, I'm attaching the green lead from the common point of the switch to the other lead on the Vactrol. Now the other side of the resistor, of the pitch control, I'm going to attach to the switch. So in the switch in this position, the LDR should be disengaged, and our pitch mod should work using the knob. Alright. So far that is working, so let's try to switch to the LDR. So I think what's happening is with these set in straight parallel, it's making the resistance too low. So I think I do need to desolder one of the wires from the pitch control. That's a great example of why the little alligator clips are so handy. I was able to just try wiring that up without having to solder or mess with anything, and try to remember how this all works. Now, it doesn't matter which one of these we desolder. I'm just going to go for the outside one because it's easy. Here comes the fan. Alright. So we use my black wire to go from the I'm going to use my black wire to go from the pitch control wire and we're going to go up to the common point of our switch. Now the green clip is going to go back to our original control, the potentiometer. And the red is going to go back to our Vactrol, which I realize now is off screen, so I'm going to try to find something on screen to put it. Perfect. Alright, and so the last thing I need to do is hook up the other side of this Vactrol, connect it to the shared point on our potentiometer. And that's because we really only need to disconnect and reconnect to one side of our kind of pair that creates the resistance. And whichever side is connected through this switch will complete the circuit, and it will utilize that resistance. Either the resistance set by the knob, or the resistance coming out of our Vactrol. Memory serves. That's how this works. We're about to find out. We'll test it out. So knob control works. So I'm not getting great results no matter how I rig it up. Basically, what I think I need to do is just try out a different LDR value. Sometimes that happens, especially if you're experimenting using, a bunch of clip together stuff like this. You may remember something working out and then you try it again. You're just not happy with it. So let us cut this guy loose. My camera overheated again, and today is the next day. Sorry if this is ends up being a really abrupt or super messed up cut. I've got to figure out some way to keep this camera from overheating this summer here. But anyway, in the meantime, where we left off, I decided I'm going to try out different values of LDR. The one we were using was a 5606, and I think the range of resistance just isn't high enough to really make an audible difference with this control. I have jotted that down as what I used in the past, so this is a pretty good example of why experimentation is super important, and it is one of the more interesting things about circuit bending. I feel like that makes it more art than science, right? Yeah, you can kind of math things out and get a rough idea, but apparently, at some point I really liked how that sounded, and now I'm not getting the sound I want out of it. So what we're going to do next is just experiment around and find something that I am happy with. And I'll take you all through that process. So this ends up being a pretty good example, I think. So off camera, I did cut off the shrink wrap from our LDR. Watching someone do that with one hand would have been pretty painful. So this is one of the things where rebooting this with some light editing, I think, is a good call. Versus making them all watch that in real time if I was doing this live. So what I'm going to do, I'm actually just going to set this piece of shrink wrap here. We're not actually going to shrink it. I'm just going to kind of use it to hold things in place. I'll cover it with my hand when we test. Just kind of get a better idea. For now, let's take a look at what different options we have. So we've got a 5539. It's roughly a 50 to 100K. And this 5M here, that's when there's no light. It jumps up to 5 mega ohms of resistance. 5549, that's 100 to 200K. Those are both a little bit too high. So I'm going to set the 5539 aside, because that might work for us. The 49 seems too high for now. A 5537-2. Again, how they mark LDRs is kind of a mystery to me, but this one reads 30 to 50K. Since that's pretty close to our pot value, I'm going to set this one aside as well as a potential good fit. We've got a 5537-1, which is a 20 to 30K. That might be a little on the low side. It could work, depending on what we find. And then we've got the 5516. And that's a 5 to 10K range, approximately. The last one I've got is a 5528, which is 10 to 20K. Now, the 5516 and the 5606, it is possible that I kind of just got those backwards. So, I'm putting this stack as like, potentially these will work, but I think they might end up being a little low. This one definitely seems too high. Set it aside in the other direction. And the first ones I'm going to try are the 5539 and the 5537-2. It's because our potentiometer control goes from goes up to 50K. So 30 to 50K seems like a good place to start. What I am thinking might happen is, since that's again at the higher resistance end of our spectrum, it might end up being a little painfully slow, if anything. But we'll try it out and see what we get. got that wired up to give it a little test. Let's see what we get. Okay, so it's working with the knob, which is good. However, when I switch it over to the LFO, I just kind of get that clicking sound. I'm not sure if that means the resistance is too high or too low. And remember, the higher the resistance, the slower the clock goes. So I'm not sure if that means that's ticking because the clock is so slow, that's all it can do. So I'm going to say that is potentially too much resistance, since 30 to 50 is going to be at kind of the extreme end of our range. So let's try our 5528, which is in the 10 to 20k range. Okay, perfect. So I think what may have been happening there is being kind of spotty at first, and then I adjusted one of these clips. As much as I love the alligator clips, that is one downside. When you've got a whole tangled mess of them going, sometimes something gets a little loose, the connection gets a little spotty. But anyway, long story short, the 5528 I think worked really well. I'm pretty satisfied that is working well. I'm going to update my notes. 5528 is actually better for this control. I'm going to do that now. One tip I recommend is keep a, whether it be a Google Sheet, an Excel sheet, whatever. I just keep a Google Sheet of different component values that I think are useful. Get one for, like, when we put together the clock mod in part 1, I talked about the trim resistor, and I came into it knowing what value I liked. That's because when I've done these before, I wrote down, hey, I like a 5.1 leading resistor. That works really well with these. And, and just remember that sometimes you might, get it wrong or change your mind later on. So I think the last time I tested this setup, I may have done something really different. because I liked that 5606 and wrote that down, but then when we tried it out, it sounded terrible. I mean, it didn't sound like anything, actually. There just wasn't enough oomph on it. So, anyway, just a little tip. Keep notes on those things. It'll make your life a lot easier, even if, at some point you have to revisit those notes and update them, like I just did. That is part of it. But if anything, I'm glad I kind of got to show the experimentation process, clipping everything together, showing, basically what that wiring scheme looks like. And, how I go through the process of trying out different values. Settling on what I'm going to use. That is good. Once again, I'm just going to use the heat gun because I have one. You can use a lighter or whatever for doing shrink wrap. Do one more test, post shrink wrap to make sure. I think honestly it's going to be okay as is. Here it is. Okay, perfect. Now before I take off all of these little clips, what I'm going to do is just snap a couple photos of what I had wired up. That way if I forget anything, I've got those to look back on. Now in this case, since I'm recording everything, I can always just look back at the recordings too. That's also just a good habit to be in. Snap pictures as you go, especially for stuff that might be easy to forget, like if my camera overheats again and then I have to come back and say, like, now how on earth did I wire that up? Being able to just look at a couple photos to jog my memory is easier than going back and looking through all the recorded footage and stuff. Earlier, both these wires went to the same control, and so I had them wrapped up. Now I'm going to undo it about halfway because now this is going to be common on the selector switch. And the selector switch, in case it's not clear, this is what lets me swap between is the control going to the actual pitch board coming from the knob, or is it coming from the LFO? That's what this switch is going to control. So common is the center pin. That's what's connecting to the actual clock modder board. And then on either side of it with the switch, Again, it doesn't matter for now which end we hook up to what. But one end will be hooked up to this knob, and the other end will be hooked up to the gosh, I'm totally blanking on to the Vactrol. That's what it's called. So let us cut some wires. As usual, we're gonna just cut ourselves plenty of wire. We're gonna need one to go from this knob to the switch, a second one to go from this knob to the Vactrol, where we're gonna tie in this second pin, since those are gonna be together, and then one for the Vactrol. So we're gonna need 3. I'm just gonna do a yellow, a white, and a green. And because I'm already using yellow on the switch, I'm gonna use my yellow wire to connect the center of this knob up to the Vactrol, create that common between them. And as I've done before, I've just cut off a pretty big heaping amount of wire, or of the insulation there, to make my little loop. Just position this knob to it's a little easier because of how that other wire is already sitting on there. The loop trick is not working the way I want it to. Instead, I'm going to make it more of like a hook. The way I can kind of go behind this other wire and hook it on. And what I'm doing is just make sure the ends are clear of the other contact, just because I don't want to have a tiny bit of frayed wire making that connection. Now, to go from the knob to the switch, I'm going to use my white wire. Before I get too ahead of myself, let me go ahead and just solder these in place. One thing I'm bad about doing is I'll try to lay out 5 different wires or something that are all just dangling. And that is not a good idea, because then one will fall off, blah blah. So better just do these 2, then I'll do 2 more, etc, etc. Here comes the fan. Green. Alright. This white wire, that's going to the switch. will stay in place. This yellow wire is going on one side of the Vactrol. I think I can go ahead and hang my green wire on the other side of the Vactrol. And this is going to connect eventually to the other side of the switch, but I'm going to do that solder separately just to make sure I don't bite off more than I can chew. So now I'm going to get those soldered in place. Here comes the fan. There's the lining. Those all in place. Last thing we need to do, so this green wire up to the other side of our control switch. What I've neglected to do is to try to kind of create a little bundle here. But let's see if it's not too late to maybe jump in now. Just wrap this around once or twice. It's not pretty, but hopefully that'll create a little bit of a bundle over to that switch. Yeah. Let's get that soldered down. Here comes the fan. noticed as I was going, it looked like I forgot to solder in the middle connection. So I just fixed that up real quick. And it is not pretty, but it would work. Alright, so now that everything I think is wired up, let's give it a quick test. Perfect. So we've got it working both on the knob and on the LFO, which is exactly what we want to see. So now I'm gonna take a quick break, but it'll be instant for you all. The last thing we're gonna do in this video is mount up all the hardware, and yeah, drill some holes in this thing. Now that we've got everything wired up, our last step is to figure out where we want to mount all the controls. And this part gets a little bit messy, so apologies in advance for the chaos. That's part of it. Some things out of the way here. Yeah, basically we have 3 switches and 2 knobs. The knobs control the manual pitch bend or the LFO speed. Then we have 1 switch that swaps the clock mod on and off, 1 switch that swaps the clock mod between LFO and manual control, and then 1 switch that changes the waveform of the LFO. So we can kind of group those together into a set of 1 knob, 1 switch, and a set of 1 knob, 2 switches. And I think it makes sense to kind of group those together. So what I was thinking is, rather than doing things kind of in the middle of his head here, you could actually potentially use the ears. So, if you recall, I'll just flip this over, you can see, yeah, the ears are pretty well hollowed out. There's nothing really going on there. There we go. Clear, you can see the trash all over my desk. So what I'm thinking is we can put 1 knob on each ear. We can have various switches, either coming off the side of the ear or on top of the head nearby. So that would kind of, rough approximation, we would have, a knob here, the switches that go with it, and then top. So I'm going to turn this inside out and just kind of start laying it out from the inside. Let's see what we think of that. First thing I want to see, even though we've left plenty of wire on all of our controls and such, we do just want to make sure we've got the reach on all of our wiring. Don't expect will be a problem. And as you can see, this is the part where everything just turns into a jumble of wires. That is the main downside of doing it this way, where you wire everything up in advance and then just mount it all at the end. Obviously, if you're mounting hardware as you go and you just run the wires between, that ends up much cleaner. But again, this is just a little circuit bending project. I, for one, am not horribly worried about that. So roughly, what I'm looking at doing is putting the LFO controls on this side, because there's fewer of them, and that'll kind of balance out with the speaker, because we're also going to add an output jack on this side. That's just kind of right here off the speaker while we are in here. Not this switch, I believe. That is the one that changes between LFO or manual control. This is the one that turns the clock mod on and off. And this one selects our waveform. What we can do is use these little support ridges as kind of a guide for switches. Since this side has two switches, we can put 1, 2. On this side, we can put 1. Again, I'm not worried about being super precise with mounting the controls on this project. If I was, I'd be masking things off and marking them a Sharpie and doing a lot of measurements. On this project, we're just going to eyeball it, because that is good enough for what we're doing. So yeah, the first thing we're going to do is figure out our drill bit size. And you'd think I'd have this memorized by now, but I always forget. So what I always do is just take out my drill bits, hold them up to whatever I'm mounting, and see if they look like the right size. So it's going to be a 5/16 bit, and that'll work for my knobs. You're going to go through here, and for the switches, it's going to be a 7/32 bit, or 15/64 would work too. Yeah, I'm just going to go ahead and drill out the 2 holes with the knob first. And again, if this was something where you want it to look really tidy, you can pre-punch where you're going to drill, get things measured out to be nice and precise. But in our case, I'm not super duper worried about that, so we're just going to go for it. And for drilling plastic, you can actually go pretty fast. And I do have a silicone mat here to protect my desk. When you're doing stuff like this, always good to be mindful of what you're drilling on top of. Especially if you work in your lap, like I often do. You don't want to drill into your leg or anything like that on accident. And I'm also making sure that the way these are stacked, I'm not accidentally going to drill through into the part that's underneath. And then I tend to work pretty messy, so I just kind of let things fly, and I'll sweep up all the plastic dust later. Choose for yourself if you wanna say don't be like me. Clean up as you go. Now, I want these to kind of be more on the top of the cat's face. So let's see if you can see. If you can see where those little support sticks, these guys, where they end and kind of go into the plastic with that curvature. I'm going to use that as kind of my vertical guide. Place it up here, right around where that is. This side. Alright. That I think will do nicely. And then if you've got little bits left, what you can do is just use an X-Acto knife to kind of scrape around the edges, clean those up. That will help everything sit nice and flush. Now, with this just being a plastic toy, I'm not too worried about the surface or the finishes. I'll just show you what I'm talking about by flipping it over. What I would have done is I would have put masking tape on the outside here. That just keeps the finishes nice around the edges. You can see here the drill kind of pulled up this outermost layer of finish on that hole. The other one's fine, actually. So I'm just going to slice this off with my X-Acto. And you can see it leaves a little bit of marring there, which I would, if this was like a commission or something like an SK1 or whatever, I'd care a lot more. Let's see, I'll zoom in so you can see it. Yeah, you can kind of see that mark right there. But for this thing, I mean, it's going to be completely covered up by the knob anyway. I'm not terribly worried about it. It's going to be fun. So that should be our rate knob. I'm just going to mark it with some Sharpie so I don't lose it. I should have done that the first time around, so I wouldn't have to do this again after moving things around. Labeling your parts makes life a lot easier. Okay. This is the mod to internal switch. So I'm going to mark that with an I for internal. And that leaves this guy, which should be LFO versus manual. Mark that with an L for LFO. This last one with a W for waveform. This is where y'all can tell me if I'm being dumb, because this is just kind of how I've learned to mount things, but I'm gonna go out on a limb and guess there's stuff I don't know about. What I'm doing here is these potentiometers have this little notch on the side, and if you're mounting to wood or something like that, as you tighten it down, that little pin will dig into the surface and keep it from twisting around. Since this is a hard surface, it's not very useful. So I always pop this off. That could be one of those things where I don't even realize it when I'm doing it super wrong. This one I've already got set up with hardware. I've got one nut on there already as kind of a depth adjustment. I just realized I forgot my glove. Got some hands going everywhere, so I'm gonna go grab that. I feel like I should probably apologize in advance if things get spotty. Hopefully I'll be able to clean it up in post, but it is really warm in here, so maybe not. I'm kind of expecting my camera to overheat and shut down on me. What I've done there is, hard to get a good camera angle on it, but basically I was just tightening that up just enough from the other side for the threads to catch. So these don't need too much extra adjustment. What you do with that bottom one is you kind of set the relative height for how much you want this knob to stick out the other end. Since the plastic on the ears is decently thick, I just tightened these down all the way, and that seems to be about right. And it's not exactly tight or anything, just getting it to the point where the threads catch. And I'm not sure if there's any particular order that makes more sense as far as LFO or knob switch or the on-off switch. I think I'm going to put on-off on the inside, oriented so that it toggles up and down. I think that makes more sense for on-off. And then the LFO knob control, I'm going to mount outside, but I'm going to mount it horizontally so that when you toggle it towards the switch, towards the knob is the control. And when you toggle it towards the LFO controls, it uses the LFO. So I think that's what I'm going to do. This is the one that I'm probably doing all wrong because switches come with, just sitting here you can see, 2 nuts, a slotted washer with a notch, and then this little ring-eating-y lock washer. And I'm going to do what I've been doing with these, but I suspect it might be wrong, so I'd be really interested to hear if I am doing this wrong. Let me know in the comments, because I'd be interested to know what you're supposed to do with these. They don't exactly come with instructions. This is just what's worked for me. So the first thing I do is add one of the nuts to set the height. Now, as far as I can tell, the point of the little tab on this washer is kind of like the tab on the pot that I took off, right? It can kind of dig into the surface a little bit and prevent rotation. But since this is a hard surface, I'm going to orient it so that that tab is just facing down. Like that. No, it isn't. Alright, since those switch holes are pretty darn snug, I'm actually going to ream them out with a drill a little bit. Full disclosure, you're not supposed to do this. This isn't how drill bits are supposed to work. Again, wouldn't do this on anything nice. But for this thing, So again, don't do that. Do as I say, not as I do. Yeah, the goal there is just to ream out a bit more material so this slides in and out easily. See, this hole I got good, the other two I did not. So, hit those again. Since I said don't do this, the better way to do that would be to use a file or an X-Acto knife and just kind of gently cut away until it fit. Or just use a properly sized drill bit. Again, for our purposes, this is a cheap plastic toy. We can mill it out with a drill bit. And I'm setting it so that when the switch is flipped up, that will mean that the mod is on. So next up I've got the lock washer. It's kind of got these little teeth on it. And this is again where maybe I'm doing this right, maybe I'm doing it wrong. I don't know. But I always put the teeth facing down. Bring one of my third hand grabbers over here. I'm just going to shove it behind the switch here, so hopefully that keeps me from accidentally pushing it out all the way. That almost worked. Okay. Again, I don't need to tighten that down or anything, just to get it enough so the threads catch. And now we're going to repeat this next switch. And this one, like I mentioned, I want to go side to side, and the white wire connects to the knob. So counterintuitive, that means I want the white wire on this side, so that way when the lever is flipped in this direction, it's going to connect up the white wire. Again, I'm not trying to get anything into its final position, just torqued down enough that it's not going to fly all over the place when I turn this over. Last switch. Yeah, this part's always a little nerve-wracking, just because it's always stressful that you're going to drill a hole the wrong size or in the wrong place. Yada yada. this one is also going to go in horizontal. This one, I don't really have an opinion on which way it should go horizontally. So I'm just going to shove it in there, and if I decide I want it the other way, I can always change it to be the other way. Last thing in this step, we've got our 3 little boards. We've got our power board, our clock mod board, and our LFO board. I've somehow routed a few wires around this ground wire here, which is not ideal. But the good news is, since we've cut plenty of extra wire earlier, nothing's in too much danger of getting all stretched out or anything. And what I'm doing is just kind of roughly finding places to position these. I do want to make sure that these 2 wires for LED bus can reach. Oh yeah, they can definitely reach this eye, and then we'll have wires to bridge across to the other eye for the indicator LEDs. Perfect. So we're going to mount this board probably somewhere over here. I do have some little mounting holes in there, but I'm probably just going to mount it using a blob of hot glue. Same thing for the power board. Just gonna hot glue it somewhere out of the way. Maybe it'd be next to the LFO. And then this little guy, because it's so small, easy to maneuver, I'm just going to mount it using that screw right there. I just realized, okay, you could see that screw at least. You might not have been able to see the other stuff I was pointing at, but that's where I ended up sticking the LFO board and the power board. So all the little boards will be kind of grouped together over here. It's a huge jumble of wires running everywhere else. Which, you know, if these wires are going to be visible to anyone but me, and I guess anyone watching, you know, obviously I'd be a lot more concerned about making sure it looks tidy, but in this case I am not super concerned at all. The other thing you have to be worried about in a nest of wires is getting interference, but since none of these wires are carrying audio signals, which are the most susceptible thing you'll usually run into for that, I'm also, again, not terribly worried about you know, signal interference with the clock or anything like that. Then I've repositioned this power board to go down here, just because I don't want to obstruct any of these screws in case I ever come back in to take this apart, or just in case, I mushed it down just right and managed to short something on one of these screws. So I was also checking under the LFO board to see if I mounted about right here, there's no screws that could possibly interfere with, or be interfered with, I should say. So with that said, I'm going to fire up the glue gun. And now I can't remember if it was in this video or the last one, but I'll just talk briefly about why people use hot glue so much in electronics projects. I'm not gonna lie, I thought it was really weird, and I wasn't into it when I first started. But it's super handy because it's non-conductive, it adheres anything to anything, and it's really easy to remove. If you just put a tiny bit of isopropyl alcohol on it, you can basically remove it without any residue, anything like that on your projects. So even if you do have to rework something, it is not a big deal to remove it. And I also mentioned that I'm using black hot glue sticks, not for any particular reason other than, black matches a lot of things with electronics. So I picked these up. But other than that, it's just normal hot glue. It's just colored black, so if you see that, don't think you have to buy special glue sticks or anything. That's just what I have. I personally prefer the high temp stuff, because I come from the south where it's very hot, and if you're a musician leaving things in your car, things can get 200-300 degrees. Hopefully not 300 degrees. Things can get close to 200 degrees, at least. So I try to use the high temp stuff just because I don't like the idea of something coming apart just because someone left it in their car. Not as big a deal where I'm at now in California, but just one of those little biases I've picked up along the way. But yeah, if you just have regular craft low temp hot glue, honestly, you're probably fine, depending on, your climate and what you're going to do with it. Shutting my camera off for a minute there, just starting to overheat, so apologies in advance if this part of the video gets jumpy at all. That's probably all it is. Alright. So all I'm doing here is I just lay down, a pretty big blob of glue, and then stick the board right onto it. That way I've got like an insulated layer along the bottom. Now if I did accidentally cover a screw or something, odds are this would protect it. That should be all of the boards held in place. Again, this nest of wires is highly unprofessional. Anyone who knows what they're doing will look at that and go, oh my god, what's he doing? And the answer is like, meh, it's not that big a deal. I'd rather, for a project like this, be able to test everything before I start drilling holes than have the insides look pretty. Because again, none of this is audio, I'm not worried about interference, anything like that. The main thing I would normally be worried about with the keys being right there is any of these wires interfering with the action. But, again, they've designed this thing really well for kids, knowing their audience. This little skeleton here actually prevents, if your kid got chunks of whatever in here, It keeps it from getting stuck behind the keys. Some like the old Casio keyboards, it's really easy to get stuff wedged behind the keys, and the keys don't work. You have to take the whole thing apart to figure that out. But, I'm going to take a break to let things cool off a bit, and then I'll come back. The last thing we're going to do is we're going to add the LEDs for the eyes, tighten down all these controls that we've just installed, and then we're going to add in that audio jack that I mentioned before. So the first thing I'm going to do is test out our indicator lights. Now, I'd like to use green LEDs for that, just because I think that'll look better. But my concern there is, if you don't already know, different colors of LED use different amounts of power. And basically, red LEDs take the least amount, which is why, I usually use red LEDs on the LFO itself. And green and blue actually take like some of the most amounts of power. So when we hook this up, we may see it look very different on a green LED. And if it looks too different, it's not going to be useful, in which case we'll just give it red eyes and kind of embrace that it's going to be a little evil looking. And these two wires, you may recall, we set those up on our LFO board. These are coming out of the LED bus. However, they don't have any resistance on them, so we're going to need to attach our own resistor for each of the LEDs. And to test this out, we're just going to bring back out our alligator clips. Color code those black and red. And again, since these use a good deal of power, I don't expect I'm going to need too much resistance. So I'm just going to grab a 220 ohm resistor to test this out. And then my green lead is going to come off the other end of this resistor. Set that off screen. Remember, our long leg is positive, short leg is negative. Okay, so let's see how this does. And this is interesting, because now, unexpectedly, the hooking up this indicator LED basically makes the LFO stop working. And I'm not sure why that would be, if I'm being perfectly honest. I'm trying to think of a few things we could try. One, always try using a diode to kind of see if maybe some sort of reverse voltage is what's causing this. That looks kind of promising, so I'll grab another lead to make a better connection. Okay, that's behaving much better. Let's see if it works while it's on. should work with 2 just as well as it works with 1, but since we're already seeing some unexpected stuff, I'm just gonna hook this up to the second one and make sure it actually does what I want it to. And what I'm doing here, because it may not be super obvious on the video, is I'm setting up a second resistor with the same value that attaches to the same negative but adds a separate resistor, because you do need separate resistors for each LED. Let's see. I managed to not screw anything up. I wonder if I actually need, just like I need separate resistors, maybe I need separate diodes as well. So there, it seems if I use a diode between the positives, these two, and use a higher resistance on the ground end, I'm going up to 1K, that seems to do the trick. So I'm going to jot that down, just so I don't forget. Okay. So I jotted that wiring down just so I don't forget, and then that way I don't have to run back and look at the footage if I decide I need to, or rather, when I go to actually wire this down. Shut off the keyboard, back on, make sure it's still working. And it's hard to tell if I'm just overthinking it or if it seems like the LEDs are a little bit out of sync. Okay, that works great. So what I did is, rather than having the diode just going between the two LEDs, I just put it between the main power in prior to reaching both the LEDs. And then the other thing we're going to do, like I mentioned before, is add a audio jack. I'm going to use a 1/4-inch jack, it's pretty common. And I think I'm just going to add it in up here, so to kind of help balance things out. So over on this side we've got the 2 switches, and over here I've just got the 1. So I'm just going to add this audio jack right here, I think. So I've got my drill bit already loaded here. That's going to be loud for just a second. Again, this is not a very fancy project, so I'm just eyeballing roughly in line with the switches. So what I'm going to use next is one of these stepper drill bits. And these are great because you kind of just work through each step until you get exactly what you need. The only trick with these is sometimes it's really easy to accidentally go too far and drill out a couple of steps instead of just one. These, I try to mount them to make the, so this little clipped corner is the ground, and then the ones to either side of it are the left and right channels. So I'm trying to rotate this so that those are immediately accessible. These other two contacts, these are switches that connect to the left and right. So for example, you can wire this up so that when nothing's plugged in, it uses the speaker, but when you do plug in the audio, it disconnects the speaker. And another thing you may have noticed is that this is a mono keyboard, and this is a stereo jack. So I'll talk a little bit more about how we're going to not really convert it to stereo, but basically we're going to put the same mono signal on both sides of the stereo jack. That way if we plug it into a stereo source, we get something on both the left and right channel instead of just hearing it on one side. So right now we've got signal running straight from this board to our speaker. We have these two connections right here. So what I want to happen is I'm going to reroute these up to our jack. I'm going to connect those to our ground point here, as well as our inputs. Or I guess outputs, really, the cable connecting pins over here. Then I'm going to reconnect the speaker to one of the speaker disconnects, since there's just one here. So and that way when it's unplugged and nothing's plugged into the jack, this will be in contact with our input. That means we will get the input signal coming out. So before we flip things over and actually I've got a couple more holes to drill, so I should probably finish drilling holes before I do any more wiring. Now that I think of it. So put a pin in that. So as you can see, here's where our controls are mounted. So this guy fell out, but I'll get that put back in. And then those LED indicator lights that we were testing out, we're going to put those on the eyes because I think that looks cool. And what I'm going to try to do is just drill out this little white spot and then install these little LED lamp holders here, since they are just about the perfect size. Since this, I want to be a little bit more precise. One quick and dirty trick you can do is just freehand a little cross. And you can see my crosses doesn't create a perfect intersection, but it can show me which direction I kind of need to move in. And that'll get you good enough to the center of the circle. What I'm also going to do is use my X-Acto knife, create a divot. That way my drill bit will have something to kind of catch into and won't slide around on me. Go back to my 5/16 drill bit. I believe that's the right size for these, if memory serves. This one ended up slipping on me a bit, but otherwise not too bad. Did a pretty decent job of getting those centered. Since these are flared a bit. And that's gonna help a lot. Especially on this one where it slipped a bit on me. There's a tiny bit of white peeking out. Let's just clean that look up a bit. I'm going to go ahead and just color the white in with Sharpie. Not a big deal either way, but a nice little detail that'll help it look cleaner in the long run. And as you might guess, I've just got plastic all over the desk now. I get that, it's fine. I'm not a very tidy desk person. So these little nylon nuts go on the back of these. Plant folders to keep them in. And they also kind of squeeze down on these internal rubber pieces, which is why I'm not tightening them down all the way. Those don't really need to be torqued down or anything more than just hand tight, so that's all I'm doing. Just need to hunt down the hardware for this knob that fell off. Glimpse of just how messy my desk is under here. that guy in again. So next up, we'll go ahead and wire up our LEDs as well as our audio jack. So let's start with the LEDs. First thing I'm going to do so what I've done, I've just got that diode wrapped around the positive end of this first LED. I'm just going to go ahead and get that diode soldered in place. Alright, here comes the fan. Hopefully it wasn't too jarring, but my camera overheated again. I think I've got an idea figured out, so that won't happen as much in future videos. But anyway, while I was waiting for it to cool down, I went ahead and just did some boring stuff that I don't think anyone's going to be terribly upset to miss out on, and I'm just going to talk through that right now. The main thing was I just finished wiring up the LEDs, just like we had done with the jumper wires. So, just to talk through that, coming off of our LED bus, I have positive going into a diode, just a 1N, what is it? It's a 1N4148 diode, specifically, but just a small signal diode. Then, coming out of the diode, we have going into the positive of both of the LEDs. Then the ground side, I have going to both the negatives with a 1 kilo ohm resistor. Again, just like we had wired up with the alligator clips. The other thing I did is I went ahead and tightened down this hardware so it's not wobbling around. I figured watching me do that with a goofy hand, no one was going to be terribly bummed about missing out on that. And then if you're super eagle-eyed, you might see this chunk of electrical tape here and think, hey, that wasn't there before. While I was tightening the hardware, my hand got away from me a little bit, and I accidentally broke the ground wire coming off of the battery pack. So I just replaced it with another wire, and this is just insulating the solder joint from that repair. So all in all, I did not miss much. Next thing we are going to do is wire up our audio jack, which I also tightened up into place. You may remember earlier I was talking about this horrifying nest of wires. I don't really mind much, just because this is all signal stuff, there's no audio running through this. However, once we wire up this audio jack, those wires are going to be carrying audio. So to keep any of this jumbled up mess from interfering with the audio, we're going to be using shielded wire. And shielded wire basically just has, a certain number of cores, which is individual wires inside. And then there's like a metal mesh around the outside. And then the outer layer of insulation. So inside this thing there are 2 wires and a metal mesh. And basically what we're going to do is we're going to ground the metal mesh and use one of those wires for ground as well. And then that way our audio signal carried by the last remaining wire is nice and shielded, and we don't end up with any signal interference from, all this rat's nest of wires carrying power and whatnot around. So let's talk about how we're going to wire this up. As I mentioned earlier, there's only one speaker. This is a mono device. This is a stereo jack. So what we're going to do, we're going to take these. Just make sure these are the right ones here. We're going to take these speaker wires. We're going to interrupt them to hook up our shielded wire. We're going to take those up to the audio jack. And what we're going to do is we're going to take the positive, and rather than just connecting that to either the left or the right, I'm actually going to connect it so that it is connected to both. Similar to what we did with our LEDs and a 1K resistor, we're actually going to do very much the same thing and have a resistor on each side, both left and right, and the audio signal coming in. And what that does, that just prevents any kind of reverse feedback or crosstalk between the left and the right, since they are technically both coming from the same thing. And how that works is a little bit above my head, but the simple version is basically any electronic signal, including an audio signal, will always take the quickest way to ground. So by adding those resistors here, we say, okay, left channel going out through the left channel is the quickest way to ground, not back through the right channel. And that's how you prevent that kind of crosstalk from happening. So it normally does not take a lot of resistance. In this case, I usually use 220 ohm resistors, and I've never had any issue with that. That said, I'm not super familiar with the math of that, so if anyone has any other thoughts or has better luck with other values, I'd definitely appreciate hearing about that. But anyway, let's go ahead and start wiring this up. So the first thing I'm going to do is install my resistors on the tip and ring connectors. So if you're not familiar, a 1/4 inch audio jack, even an 1/8 inch audio jack really, comes in two flavors. One is TRS and one is TS, more commonly stereo and mono. So TRS is the stereo version, and that stands for tip, ring, sleeve. So the tip and the ring are the two audio channels, left and right, and the sleeve is the ground connection. Now in a mono, you just have tip and sleeve, so the tip carries the audio, and the sleeve is the ground. So I've got my two resistors up. Right. And I've just wound those resistors up together because, again, we're going to have a single input coming in. You can zoom in on that, actually. Alright, now you can see a little better. We've got this is the tip connector, this is the ring connector, and these are 220 ohm resistors, so that way there's no crosstalk between the left and right, even though they're coming off one single connection. And then our ground connection is going to come off of this connector up here. And like I briefly mentioned before, but I think I had it backwards at the time. These two are your disconnects, so we're going to wire these, or just one of these actually. We're going to wire this one back to, this one being the tip connector. We're going to wire this to the speaker. That way when we plug something in, the speaker gets disconnected. And when we unplug it, it will use the speaker instead. And once again, for that connection, we're also going to use our shielded wire to make sure we're not getting any signal interference. Alright, so let's go ahead and solder these resistors into place. Let's come on, here comes the fan. The shielded wire, I'm going to be a little more precious, just because this stuff is a little bit more expensive. Let's cut now to take the insulation off of these, I'm going to use a bigger pair of wire strippers. I want to say it's the second from the top. Yeah, perfect. That is the setting for 14 gauge stranded. That's what I've used to strip that. So you can see there's the metal sheath I was talking about. So what we're going to do is kind of try to pull that away. Just kind of use your finger to separate everything out. What I'm doing is on the stripped portion, kind of separating the strands out. Separating the wire ends out. And we are very much going to treat the sheathing like a wire of its own. So there we go, got that kind of wrapped up into a little connection. Next, I'm going to strip the ends off the red and white wires. I can use my small wire cutters again. When I'm done, I've stripped quite a lot off the white wire side because I'm actually going to connect that to the sheathing. I'm going to wrap those together, and that's going to be our ground connection. That way the sheathing that's running through this wire is grounded, meaning it will provide better shielding. What I'm going to do up here is I'm actually going to attach a bit of extra component end to the ground connection of the jack. That's just going to give me more area to attach, because I'm going to have multiple ground connections I need to connect. And it's just going to give me extra room to do it. Alright, so I'm going to get that soldered on. Here comes the fan. just like before. Take out the outer sheath, get outer insulation, and then get this metal sheathing stuff separated. Just like before, we're gonna wind in the white wire here. A little bit of a connection there. And then we're going to go blue to white, red to red. I think it actually matters, but it reserves. That's how they've got these wired out. What I'm going to do with these is add some shrink wrap before I solder on. So it's the green piece here. I think I can just cut this in half. Use each half for each one. What I've done there is it's probably hard to see on the camera. Basically, you just make two kind of like hook shapes, and then hook them together, and then pinch them closed. Zoom in on that. It's kind of hard to make out, but so I'm going to focus on my finger. And then we'll hold it in place so we can solder it, and then we'll that piece of shrink wrap in place to help prevent anything from getting shorted out. Alright, so here comes the fan. go ahead and heat shrink this before I do the next connection, just because I want to be really sure I don't short anything out. Yeah, I'm just going to use my little hot air gun, which you could use a lighter or whatever. It does not have to be fancy. We're going to do the same thing for the positive connection. Shrink wrap on before I forget. I'm really bad about forgetting the shrink wrap until it's too late. Which isn't the end of the world. You can always use regular electrical tape or tight spaces. Liquid electrical tape is also really good. Just like before, I've made two little hooks, pinched them together, and I'm using this clip to put a little tension on it to hold it straight. If you have it going off at a weird angle, the shrink wrap doesn't work as well, so it's helpful to get those as straight as possible. And here comes the fan. Alright, and just like before, I'm going to shrink wrap that straight away. So I'm going to next connect up this speaker. The first thing I'm going to do is just shuffle these wires off and out of the way. And then we're going to do another run of the shielded wire. So here comes the fan. I'm going to get those desoldered. Another thing I did, I just marked with a Sharpie in black where the blue ground wire was. Again, I don't think it matters with speakers. You can go either way, but it took 2 seconds to do that, so we may as well. So next, we're going to prepare another length of our shielded wire. And with this stuff, I will just cut a little extra too, because again, there's plenty of room inside this project. I'm just being a little bit more cautious than I was with the regular wire, where I just went willy-nilly, just because the shielded stuff is a little more expensive. And one nice thing about electronics, nothing is terribly expensive on its own. But, just like before. Bundling up the sheeting there. Soldered in. Here comes the fan. Alright. Next up, we are going to connect the speaker wire. We're going to have our ground here in this ground connection, which is why we made some extra space for it. And then we are going to have the hot connect to this pole here. That's the tip connection. And that way, whether it's a it doesn't matter, we could use the tip or the ring, but we're going to use the tip because it's a little easier to get out. That looks beautiful. So we'll go ahead and lump that in and get that soldered together. Here comes the fan. Alright, and while I was in there, I went ahead and tinned up the hot connection and got it wired up as well. And we should, theoretically, be all done. But before we get too far along, I I'm going to do some testing. So just to recap our controls here, the LEDs on the eyes should show us what the LFO is doing. Here we've got our 1/4 inch jack. Here we've got the wave selector for our LFO. Here we've got the rate selector for the LFO. Over here we've got the on-off switch for the pitch bend, as well as the selector that says if we're going to adjust it with the knob or with the LFO. Let's cut it on. So you can see our LFO is going pretty quick. It's really quiet. And it is occurring to me now, with the way I've wired this up, for it to come out of the speaker connection, it's going through one of the 220 ohm resistors. So I'm going to try to short that. Let's see. Basically removing that resistor. We'll get our volume back. Alright, that would do it. I'm just trying to think for a minute because I don't want the crosstalk, but I also don't want one channel being quieter than the other. I think just for the sake of this project, if there's a little bit of crosstalk or this isn't a particularly fancy application, so I think what I'm going to end up doing is basically just removing these resistors. And that is a good illustration of why we test everything before we start putting stuff back together. Alright, so just to show what I was talking about here. Here I've got our audio connection coming in. It's routing through the two 220 ohm resistors. Even though those are itty bitty resistors, audio signals are pretty windy. So the audio signal is being dampened enough by that when it's coming out through our speaker connection, it's not really driving the speaker very hard, so we've got like no volume at all. So I'm gonna do is just remove these resistors. What I did there, in case it's hard to see because it's kind of a jumbled up mess, basically I just trimmed out the resistors and left in enough component leg that I was able to just kind of bend it all together. So now what I'm going to do is basically turn that into one big solder blob, so that way left, right are both connected to our single output. So here comes the fan. Let's test this out. out one more time. There we go, that's a bit of volume. Alright. That is looking good. So, next up, I am going to go ahead and shut the camera off to let it cool. And then we're going to try it out wired up through the speakers.
The little kid forgot how to meow. All it could say now, all it could say now is woof woof and bow.
That is looking really good. We've got our output working nicely, all our controls work. I did hear a little bit of noise in the background while I was testing it out through the headphones, but A, on something like this, I don't mind too much, because that's to be expected. And B, as I wrap up here, I'm going to go ahead and do a couple things that may help with that. The first of which being, I'm going to route these audio cables just kind of away from the LED and rate controls from the LFO, because the noise I heard was fluctuating in time with the LFO, so in spite of my best efforts, I'm still getting a tiny bit of interference coming through. And the other thing we're going to do, I've got the hot glue heating up now. One, we're going to go ahead and slather a bunch of glue on these LEDs from behind. One that will kind of help insulate them and maybe prevent some of that noise. But mostly it'll just keep them from rattling around because the LEDs, I don't know if you can see that, they are kind of loose in there. So I usually slather the back with some hot glue. In this case, we've got the added benefit of it may help with some of that erroneous noise I was getting. And again, if it doesn't, I'm not terribly concerned about it. Something like this is bound to be noisy, and if I was going to do some sound design or samples or whatever with this keyboard anyway, I'd probably still be running it through a filter to clean it up, so all that noise is pretty easily cleaned up. So, like I said, I'm just going to slather the back of these LEDs with hot glue. I'm going to do the same around this audio jack. It's shielded the rest of the way through, so if anywhere's getting some signal interference, it might be right there. So a little extra insulation might help that out. I'm just putting some hot glue blobs around the controls. Just keep them from accidentally migrating or something if the hardware gets a little loose. As well as providing a little bit of insulation on those controls. And I think with that, we are pretty much done. I won't bore you with it, really. The last thing we've got to do is just snap on the back and then work in all those various screws. Alright, so I think we are all done here. So yeah, I just want to say thank you again, everyone, for tuning in. Definitely really appreciate it, especially if you watched all the way through both of these videos here. As I mentioned before, if you're super into this, or you're not super into it, if there's stuff you wanted to see that you didn't get to see, if I showed too much stuff, super up into that feedback. I'm kind of just getting rolling here. And on that note, as something that's relatively new, it's definitely a huge help if folks like or subscribe. I know it feels really weird to be like, oh, like and subscribe. It feels super lame, actually. But it is actually a tremendous help as a small channel to get YouTube to like pay attention to this stuff. And then on a personal level, it's actually just way more, way more encouraging if there's like comments and stuff like that. Comments, likes, subscribes coming in when I upload. I'm way more likely to actually like do it. Because I've had this channel for forever. I've just been really lazy about making videos. So again, major appreciation to those of you who've made it through. You don't have to like or subscribe or anything. No peer pressure, but it is a tremendous help and it is free to do. So definitely encourage that. If you want to see more of this stuff from me or from other folks, that's a great way to kind of show your interest in that. Again, any questions, drop them in the comments. If I did something a really stupid way and you know a better way, please drop that in the comments. I love some good constructive criticism, as long as it's constructive. So please don't hesitate to keep that stuff coming as well. So anyway, I'm going to stop yammering. Again, thank you so much, and yeah, see you all in the next one.